Hi, everyone. So we are starting chapter 8, definitely more than halfway through the course. So we talked last time, chapter 7 is really what started to get us into this inferential statistics. It's kind of the background of it. And now with chapter 8, we're going to be starting to look at confidence intervals. And what confidence intervals let us do is construct an interval with plausible values. So basically, by the end of this video or by the end of the unit, you'll be able to construct an interval and you'll be able to say whether a hypothesized or a predicted value is even a possible answer, depending on whether it falls within the interval that you construct or not. So confidence intervals. So when you're constructing a confidence interval, there's three main parts, but really there's two parts to a confidence interval. There's a point estimator, and your point estimator is right in the center of your interval. So it's what you're going to add and subtract your margin of error to and from, I guess, to construct your interval. So a point estimator is the statistic that provides the estimate of the population parameter, and it is always right in the center of your interval. Now, in another statistics course, or in the real world, if you rather, you can create confidence intervals based off of many, many different types of data or parameters. But in stats, in college stats and AP stats, we only look at two different ones, and that would be proportions and means. So the next 8, 9, and 10 are all going to talk about proportions and means and what to do inside those sections. So I gave you an example of to know which one, because I think that that's where people tend to struggle, is they're like, well, which one do I use? Do I talk about a proportion or a mean? So if you read the example on the left, the example about the math department, they want to know what proportion of its students. Right there, I know I'm using a proportion. It also says they take a random sample of 100 students and find that 28 own a graphing calculator, which means that my point estimate here, I'm going to abbreviate that with P and then I, point estimate, would be 28 out of 100. Okay, or if you would rather, 0.28. That would be my point estimate. That's going to be right in the center of my confidence interval. Now let's compare that with the example on the right, which is means. And it says the makers of a new golf ball want to estimate the mean distance the new balls will travel when hit by a mechanical driver. They select a random sample of 10 balls and they measure the distance each ball travels after being hit by the mechanical driver. Here is the distances in yards. So again, your keyword here is going to be they're looking to estimate the mean difference, okay? So either way, it'll be pretty obvious. With means, you're going to be given data like down here, and they're going to ask you to find the mean and the standard deviation, or they might give you a mean and a standard deviation. Proportions, they won't give you a mean and a standard deviation. They're going to give you a proportion. There was something else I wanted to say as I was reading through that. Oh, with confidence intervals, something to know, they're always estimates. You use that to estimate. So you estimate a value, so whether it's a proportion or a mean. Again, you kind of construct a interval of plausible values. Okay, so here are your definitions. So a C% confidence interval, C%, that's kind of funny. The main ones we look at are 90%, 95%, and 99%. Those are going to be the three intervals that we usually construct. So replace that with C and it may make more sense. Gives an interval of plausible values, plausible or possible values for a parameter. And the interval is calculated from the data and has the form. This is really important right here. It is in your homework check, so you may want to jot that down, that you do your point estimate plus or minus your margin of error. So your point estimate, like I said, is right in the center. So you get this interval, of all these values, and your point estimate is right in the center. And then you add a value and you subtract a value from that to get to those, to get to the both the bounds of your interval there. So you take your point estimate and you add and subtract your margin of error, and that will give you the ends of your intervals. The difference between the point estimate and the true parameter, that's your margin of error. Your confidence level gives your overall success rate. I love talking about confidence levels. We'll talk about it briefly in class, but there is a big difference between a confidence interval and a confidence level. And I believe I get into that in just a moment. So I'm going to pause for a moment till we get to the next part. Interpreting these words right here. Let me see. Do I have is this a highlighter? No, it's not. Sorry. Trying to experiment here. So these words right here, we are C% confident the interval from blank to blank captures the, and then parameter and context. Super, super, super important. I would normally have written this on the board, and every time I ask you to interpret a confidence interval, that's the words that you use. Do not use your own words. Do not make them up. Use my words. So we are 95% confident that the interval from blank to blank captures the, and then give me some context. Very, very important. Just use my words. Don't make up your own. The second part is the interesting part about what a confidence level is. So the second part is confidence level. If we were to take many samples from the same size from this population, about 95 of them will result in the interval that captures the actual population parameter value. What does that mean? Okay, so that means you have a population of whatever. Okay, so I've done this before with Twix bars. I think we said the right and left. I've also done this with, I don't know, just a bunch of different things. So basically, you have something over here, whether it's people or candy or tools, whatever it is, whatever that you're sampling. This is my population. Okay, so you take a sample from the population. Okay, from that sample, you construct a confidence interval. Okay, so when you calculate your interval, you might get an interval that's that length right there and goes through those numbers. Like pretend it's a number line and I've plotted it and it goes through those two numbers right there. Okay, so that's sample number 1. You put those people back in, or you put those candies, whatever it is, you put it back in, and you take out another sample, which is sample number 2. Now in sample number 2, you're going to get a different confidence interval. They all won't be the same because you just took out a different sample. So this time, maybe my interval looks like that. Okay, then I take out another one. And this time, my interval is going to look like this. And then sample 4 maybe looks like this. And you get the idea. Like, you just keep taking different samples and constructing these different intervals. And again, they'll all be different intervals because you're getting different samples. So they'll all look, I don't know how many I've done here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll throw one right there, 10. Now, if this had been, let's change this to 90% because it's easier to see. So I've taken 10 different samples. So I'm up to my 10th sample. So there's 10 lines there that all represent different confidence intervals. Okay. Now, if this is 90%, then that means that 9, make that one a slight bit longer, 9 of the 10 confidence intervals will go through the population parameter that you're trying to estimate. Okay, so whenever I ask you to think about a confidence level, picture this in your head, that if it's 90%, then 9 out of 10 of the intervals will go through the true population parameter, the thing that you're trying to estimate. Okay, so 9 out of 10, 95. So if it's 95%, I'd probably have to do 100 different intervals to show you what that looks like, and all but 5 would contain the true population parameter. Okay, so that's confidence level. Whenever I ask you to think about a level, look at that. Okay, I promise we're almost done. I don't want to take up too much more of your time. Really important, don't confuse intervals with levels. They are different intervals. Again, you're going to use my words and what's highlighted there in the yellow. We are C% confident that the interval from blank to blank captures. If I'm asking you to interpret a level, it's that if you were to take many samples of the same size and then about whatever percentage will result in an interval that has the true population proportion. Okay? So I had the answers here, so I'm just going to flip over really quick to 8.1 because I think that I have it. I just won't be able to write it, but I already typed them in. I don't know why it didn't refresh. So we'll just go over here really quick. I can't write anymore, but I don't think I can write. Maybe I can. So a large company is concerned that many of its employees are in poor physical health, blah, blah, blah. They have a 95% confidence interval, and the, whoops. The 95% confidence interval goes from 4,540 steps to 8,473 steps. So that is your confidence interval right there. Here is the interpretation. Again, that is wrong. Sorry about that. Let's go back to this page so I can write it out for you. I did the wrong one. Confidence interval, that was the confidence level. So confidence interval, we are 95% confident that the interval from 4,547 to 8,473 contains the true, what was this? Average number of steps taken per day at that company. Okay, we are 95% confident that the interval from blank to blank, not blank, blank, 4,547 to 8,473 contains the true average number of steps taken per day. Okay, so that is the confidence interval interpretation. Again, I just copied the words from the previous page, threw in the numbers, and threw in the context. B, what is the point estimate? This is correct. So the first thing you do is you need to find the middle. So I took the two numbers and I added them and then divided that by 2. So that will give me the middle of that interval, which is 6,510. That would be my point estimate. The distance from the middle to the end will give me my margin of error. So I took the end and I subtracted that middle, that point estimate, and got 1,963. So this right here is my point estimate plus or minus the margin of error. Okay, so that's also in your homework check, so make sure you take some notes on how to do that, or you can refer back to the video. And then they want us to get 10,000 steps per day. Do we have convincing evidence that they're not meeting the guideline? And that is yes, because go back up to that confidence interval right there. 10,000 is not included in that interval, which means that it's lower. The employees are not meeting the requirements. Okay, this is the same thing. I'm just going to pause for a minute. You can copy this down or read through it. You don't need me to read it to you. One is the confidence interval interpretation, and the other one is the confidence level. How to calculate a confidence interval? You take a statistic that's also your point estimate right there. Your point estimate, and then you're going to add and subtract a critical value. We're going to go over next time how to calculate a critical value times the standard deviation. If you remember from last year, we often used 2 as the critical value because you were approximately 2 standard deviations away. But again, we'll talk about how to do that next time. Oh, that's it. So that brings us to the end of the video. So where you need to focus is basically in the homework check. I'm going to give you a question and you're going to have to interpret a confidence level. You are going to have to find a point estimate and a margin of error and say whether a value is plausible or not. And then you'll get some practice in the activity. Okay, so again, confidence intervals are used to estimate. Yeah, I think that's it. So confidence intervals.